Hello and welcome back to part two. Yes, two, it's Saturday. It's not because it's Saturday, it just happens to be Saturday, and this was too big for one live stream, so I'm making two today for this particular effect. And so we're going to talk about a problem that you probably ran into if you actually were to render out what we had. So with no further ado, let's go over to Natron. Whoops. I want to make sure I'm in the corner. Okay. Alright, so we left off and we had our view and we added our card 3D. And we made this lovely blur that came out and it blurred in as our Natron came zooming up to through the flames. But the problem is that while we've added motion blur to our text, one of the things that we didn't do is we didn't add motion blur to our GLSL node. And we have a problem here. And I'm going to do something. And what's going to happen right here is we're going to crash. I'm going to show you. Well, we're not going to crash right away. Actually, we are going to crash right away. So how do we add motion blur to a GLSL node? If we click on our rolling fire right now, there is no motion blur option on here. So the first thing you say to yourself, well, maybe there's something that we can do to give this motion blur. And you say to yourself, well, what would that be? Okay, well, the first thing that comes into my mind is, okay, well, motion blur is some form of temporal blurring. Temporal means time-based blur. It looks ahead at frames ahead and looks at time behind. And this is where it gets tricky with GLSL nodes, because if we go in here, if we actually look at our time filters up here, and I want to make sure that it's not blocking. If I look at my time, I have a thing here called time blur. Well, how convenient is that? We'll plop a time blur on here. And as soon as I do, something has gone horribly, horribly wrong. At least it should. There we go. Natron has crashed and I'm back at my desktop. And everything, the world's gone horribly wrong. Boo-hoo, boo-hoo. All right. Cheer up. It's not the end of the world. Let's talk about this. And we're going to just, for the moment, I'm not going to actually open up our chiseled font. We saved it just before this point. We'll open it up in a minute. And because we need to approach this from a slightly different way than, or a slightly different standpoint than you might think. And I'm going to take you through what most people might go through first to show you that you can get to a point where you may think you have something functional, but it doesn't function yet. Okay, so here we are in a fresh copy of Natron. We're going to pull up and we're going to add our, what was it called? Rolling fire. And we'll link it in. And, it gave us an error. That could be just my card. So I often have to relink it a second time. It's not a big deal. So I've relinked it. It's update. It's working. Here I'll show we have rolling fire. All right. I'm going to talk about a concept here. The problem with the GLSL nodes is that they don't grasp time. They are generated on the fly. In fact, what happens is it's creating this texture at every frame as it's being created. It doesn't know what the previous frame had for information, so there's no way for it to look ahead or look behind. So you say to yourself, okay, so obviously the problem is what the frame or the time blur does is it looks to the next frame and it looks to the previous frame, but it can't do that because there's nothing there. There's no GLSL information. So what we're going to, the first thing that goes through your mind is, aha, I bet we can put a disk cache on here. So, aha, let's try that. Disk cache. And there's our disk cache node, and you'll notice that I put it off to the side. That's just the normal habit of the disk cache. And once I put it in here, I say to myself, aha, we have a disk cache node. Now if I put my time blur like last time, will we crash? Time blur. Whoop, the time blur did not attach to the disk cache node. And we connect up to it, cross our fingers, and oh, hey, did you see that? It sort of shifted a little bit. The time blur shifted. It gave us a frame, or it gave us what we think we want right now. It looks correct. And in fact, if we back it up and play it, it will play correctly. We're actually getting motion blur with a GLSL node, but we're not really. And this is an important thing. If we actually try to render this out, you would sit there and you would get render fail, render fail, render fail, render fail, render fail. And it has to do with the fact that Natron currently, and this might get fixed in the future, the problem is that the disk cache node, for some reason, will not create a cache that's bigger than whatever our project settings are, at least not from the standpoint of a GLSL node. So, and what we're doing is we're creating actually a whole lot of extra frames in here. So I'm going to save you the trouble of having to go through this and pull out your hair saying, why isn't this working? Why isn't this working? Why isn't this working? And we're going to just delete this. We're going to delete this. And we're going to get into, this is to save time. What we're going to do is we're actually going to, there's other ways we could go about this. We could pre-comp this. Now, pre-comps are good. And in fact, I'll show you how we're going to go about this. We have to start thinking outside the box a little bit here. With the GLSL node, and when we attach the disk cache node to it, and then applied the temporal blur to it, it was generating 10 extra frames per, frame of our motion blur. But when we're rendering out actual frames, we're not actually blurring this as it's going out to file. We can't do that. We already established that. So we need to actually get 1/10 of this information and save it out to our rendered file. So how are we going to do that? Well, let's go back up here to our GLSL node. And in rolling fire, what we need to do is slow this down. Now we see speed up here, but for this particular node, speed is the wrong attribute. You don't want to try and get this down using that. What we want to do is slow it down with acceleration, and I'm going to demo this. We're going to render this out quickly, and we're going to watch it, and we can see how fast this is going. All right, that's how fast it's going. If we take our acceleration and set it to 1/10, which would be, it's currently set to an acceleration of 1. So if we set it to 0.1, that's 1/10 of it. And we go back to the beginning and we hit play. Now our animation is playing back at 1/10 of the speed. But at 1/10 of the speed, that means we have to render out 10 times as long an effect, which means that when we go to write this out, we would have to make it, we would have to increase our project length. So we sit here and we hit S to bring up our, whoops, oh, there we go. Oh, I hit W to write our node. I created a writer node. That's all right. We hit S to bring up our project render settings. And you can see that our last frame is 250 currently. So to make this, I would have to set that to 2000 500 frames. That's a really long animation, and I don't feel like rendering this out to wherever at this point. So fortunately for everybody here, I've already done this. Except for I am going to go over a couple of things that people may not know, which is we're going to make one of the things we didn't do in our previous effect is we didn't actually apply the node the way the chiseled font. I wanted it to look like it was all reflective and pretty and things like that, and it wasn't looking all that pretty and reflective. So how are we going to do that? Well, I guess I've got to. I'm going to open. Let me just think about this. Yes, I'm going to open our recent project, which is Chiseled01. This is our file. And I've rendered out a few different types of... I'm replacing our rolling fire background here. And we're going to replace it with a more interesting set, and I've got it saved off to the side over here. I just need to bring it up. Just give me a moment. All right. So, I'm going to bring up this. All right. So I have this rolling fire, and I have 3 different things here. I have a folder full of EXR files. And the EXR files are saved out in a format, and I'm going to show you guys how I saved it out in a moment. But these other 2 are QuickTime files, and you know what? I was too hasty on my deleting of that. Now I'm going to actually revert my project here. Let's reload, discard. The reason I want to do this is I want to, we're going to put our disk cache here. Let's put a disk cache, whoops, I wanted a disk cache, and connect that up here. And then I'm going to, we're going to go ahead in time to this point, because what I want to do is I want to have my rolling flames also reflect off of the text in a really interesting way. And I already found the merge look that I want, and I will show you guys the merge in a moment. But first, we're going to blur this. So as we know, the rolling fire, it works fine if I put in the time blur right now. So time blur. We're going to just build this really quick. Time blur here. Put the time blur in. That gives us a blurry background for the fire, which looks great, except for it won't render out, unfortunately. And so now what I want to do is I want to put this over our text as it's coming flying at us. And so I'm going to use this as our background. So we're going to put a merge, and I'm going to bypass this. And I'm going to take our card 3D as our source. Okay, so let's look at this. I think I want to do that. Actually, I have these reversed. I want to use my card 3D as my background, and I want to put the time blur over it, except for I'm going to reverse it. So I want to, I'm just thinking about this. Is this what I want to do? Yes, I want to reflect, I think it was. No, I didn't want to do that. I did something. I got ahead of myself. I did not do that. I used a transform. Uh-oh. Mirror. There we go. Sorry. I reflected it. Then, okay, so we see what that did. The reflection, oops, I don't have it set to. I'm going to horizontally flip it. Okay. So it's flipped it from one direction to the other. That way it's going from the opposite direction. That will make it look better when we merge it over. Now we want our card 3D. We're going to put a merge node in here. We're going to merge this on top of it. And we're not seeing much. It's not looking overly impressive because we need to mask it. So we're going to mask it. There we go. It's not looking all that impressive still. Okay, we got fire going over it. It's not overly impressive. Let me try running it out of this. Oops, running it out of our card 3D. I just like we want our alpha channel to come from the card 3D, not over here, because this is animated. This is going to animate our mask, but at the same time, I don't want it overlapping my B input going into my merge node. Okay, so I'm masking it. I've taken the mask and I've piped it in just by pulling this up a little bit. It looks a little funky, but that's okay. All right, now we need to find a nice look for this. So it just so happens that I know that the one I want to do is grain merge. I really like the way this creates this nice yellowish tint up here and with black outlines. And when we put it over the fire, it looks really, really cool. Okay? Except for that we can't use it because our rolling fire can't be used. Okay? So how are we going to fix this? We need to pull in one of these rolling fires. Now, I'm going to tell you the difference between these three files, okay? And it will become apparent in a moment. This first rolling fire over here is just a standard 8-bit ProRes rendered file, okay? This second one is the same file rendered in ProRes, but instead of it being 8-bit, it's 10-bit. And I'm going to explain, while ProRes can output 12-bit technically, Natron uses FFmpeg, and FFmpeg is actually limited on the maximum bit depth that it can go, and it can only go up to 10 bits per channel for its color channels on its output, which for most situations 10-bit is not a big deal, but we're still going to wind up with a weird result. So I'm going to actually bring all three of these into our Natron project over here. And I think there they are, all three here. And so let's first start off by figuring out, these are all, by the way, 2,500 frame animations, and they're very long. But the first problem we're running into is they're way longer than our project is, and in fact our project's length now has increased to 2,500 frames, so we need to fix that. That's something that always bothers me a little bit. So we'll hit S and we'll pull up our project settings and we'll go back to 250 frames, and then we need to shrink each one of these back down to 250 frames. Because if we take our time blur and just put it over one of these, what happens is we're not actually seeing, this is the same as if I piped it into our, well, sort of the same as if I piped it into our rolling fire. It's slightly different because we're getting a different result, because our GLSL is showing us actually frame, uh-oh. I may have... Ooh. Uh-oh. Oh, we got lucky. We got really lucky. Didn't. Huh. That's very interesting. I'm hoping that it just realized there was a cache for it. But anyway, we're not going to touch. I almost crashed Natron on us. All right. Anyway, what's happening here is our frames out of our read node are not retimed. So our time blur doesn't know how to deal with them. We actually have to give sub-frame data to the time blur node for it to retime it with. And in order to do that, what we have to do is go back into our time nodes, and we want to go to time, where is it? Retime. Okay. What we want to do is we've rendered out 10 times as much frame information in each of these, and we're going to, in order to gain access to that for our time blur, so that this actually blurs correctly, we need to change our speed 10 times as fast. We do that. Voila! We have a result that should look pretty darn close. It's 1 frame off. I'm not worried about 1 frame. So here we go. We've got 1 frame off. We wind up with something. Oh, and we're looking at the EXR. All right. So what does this mean? Let's look at our original one. In fact, before we do this, I'm going to first connect it to our 8-bit read. This is our 8-bit. It says rolling fire right here. This is our 8-bit ProRes. And I connect up to the retime frame node, and did anybody see what just happened? Did you see right here? Look at the colors of this R right here. Watch what happens here. Ready? We connect up to our original. And we have, actually, it's more noticeable on the A, right? This A, this is yellow when we're connected up to our rolling fire. When we connect to our 8-bit, it shifts to a white hue. Why is that? Well, that happens to be because this does not have the same bit depth. Aha, you see, it doesn't have the same bit depth. Well, if we can render out a ProRes file at 10 bits per channel, all right, let's do that. Let's connect that up. We connect that up, and that didn't solve the problem either. This is one of the reasons that I always tell people, you're always safer when you're dealing with things in Natron. If you're going to use a sequence from Natron, it's always better to go to rendered frames because you can get higher bit depths for your output. EXR stores all the extra information, all that extra color information that is lost with these other 2 files because they're actually stored in an integer version. And while that is 16-bit, it's an integer version. As far as I know, it's an integer version. ProRes stores it in an integer format, so it actually has a cap. And Natron works in a floating point. Well, EXR fortunately has an option to work in EXR. So if I go back here and I look at it and I connect it, oh, look at that. We wind up with a nice yellow, just the same as what we started with out of Natron. Our A and our N looks exactly the same. So this makes you say to yourself, okay, well, hey, that's exactly what I want to use. How do I do this? And what are the pros and cons of this? The pros and cons, the pro, obviously, is we get something that looks the same. Let's go back. I didn't close our other Natron file because we want to actually talk about that. So over here in my right, and you'll notice that we're doing this, we're writing this out for our flames. So up here in my right, I have the option here. It wants a file path, so we'll click on our file path, and we'll go in here. We'll go into chiseled, and I don't know if that's the right spot, but over here we're gonna sit here. We could go in here. I'm gonna just make a subfolder just to be on the safe side called EXRs. and hit OK. And I'm going to go in there, and I'm going to give it a name, Flame. And this is because it's going to be 2,500 frames. Okay, for our animation, we have to give it four increment numbers. 1, 2, 3, 4 hashtags. That means we will get 4 digits when we render this out. We want to put in .exr, and over here we want to switch this right next to it. We don't want a single file. A single file, if I was rendering this out to a movie, I would leave this on file, but in this case we want to make it a image sequence, which is going to be EXR. Notice it changed our file type down here automatically to EXR versus having to look through this entirely too long list. Holy cow, I'm not going to go through that. Anyway, we hit save. There we go. We've set it up. It comes up with our EXR options over here. So I'm going to tell you a little bit about this, and EXR has a whole lot of potential formats. And for this particular thing, we want to keep our file size as small as possible while retaining as much information as possible. Now, it just so happens there's a bunch of compression options in here. By default, it's EXR is uncompressed. If we do 2,500 uncompressed wireframes, we're going to be eating up gigabytes. We're talking like mega gigabytes of data, even at 1080p. This is going to be ridiculous. So we're going to use what I consider the most... let me make sure you can see this. Yes, you can see it on the feed. We're going to be using the most... the best compression method. Now, this is the equivalent of JPEG. This is a lossy format, and I'm going to just do something here. 1 second. I want to get my face back into our view. We're going to use DWAB. This is basically the equivalent of JPEG it's a wavelet compression version of VXR. But here's the cool part about it. It's a wavelet compression that has it can be up to 32 bits of information. So we're going to change our bit depth. When we click on our bit depth, it can be set to auto, but we're going to force it. We want to make sure that this is a 32-bit floating format. So we can go up to 64-bit. We don't need that. We could do even 16-bit. It doesn't matter. The key thing is that it's a floating point format. We want it to be floating point for it to work. But here's the thing. It really doesn't matter, because when we compress this using this, they will both, no matter which one of these we pick, even if we picked 8-bit integer, it would actually compress to the same file size. But we're going to set 32-bit float here. We're going to keep it DAW. This is going to make it very small. And we're going to go from a file size that is bigger than, we're talking huge. We're talking like probably 15 to 20, maybe 15 megabytes of file, or 5 megabytes of file, somewhere in that neighborhood, down to like 1K, which is going to be smaller than actually a PNG sequence of the same format. And we don't want to use PNG because PNG also is results of my experiences. PNG results in the similar thing sometimes. It can get weird. There are times to use PNG, but for this, we want to stick with DWAB compression. This is going to result in the smallest file size. Or I'm going to get off of the high horse. Okay? So this is what you're going to do. You render out like that, and we're going to wind up with a folder full of EXRs, and you can look at 1.7 megabytes on average per frame, which is tiny considering these are 32-bit floating point files. Okay. And so you're not going to wind up with a huge thing. It's even going to be smaller than if you used PNG. You're going to have to play if you do this with your own things, but for our standpoint, it's going to be, that's what we're going to use. So let's go back over here, and let's get rid of these others. So now we've retimed it so that we get the extra frames. So we get a motion blur. We've set it so that it is 10 times longer. We've told our frames that they are 1/10 of their size. Okay, let's go back. That was done in the other project. In this, we told it we wanted this acceleration to be 1/10 of what it originally was, so that this renders out slower. We've rendered it out 2,500 frames. We've gone back here, which is 10 times the length of our actual project file. We've told it we want to retime it so that it renders 10 times faster. That's what this is doing, this retime. We're setting it to 10 times faster. If we want it to go slower, we have to set it to a slower, or we reduce it below 1. 1 is our normal speed. 0.1 would be faster, or would be, slower. It would reduce it so that it's 10 times as long. And then we take that and we go to our time blur, and our time blur is using 10, dividing our frame by 10 frames to use as our scale to determine the amount of motion blur. And of that, it's going to use a shutter speed of 0.5, which is 180-degree shutter speed. Okay. And that is how you get actual real motion blur that matches a real camera using a GLSL node in Natron. It's a little tricky. Hopefully, at some point in the future, they will fix the GLSL nodes so that we can actually use time blur and get the disk cache and so forth. But there's other reasons that this is actually not the best way. Even using a disk cache node is not the ideal thing. Or even if we could get GLSL nodes to do subframe or automatically do subframe when dealing with the time blur, it's not the best thing in the world. Actually, I will say that if it could do it with the GLSL node or directly, it would be okay. But with the disk cache, it's not necessarily the best thing, because every time we clear our cache, we would wipe out that, and it would have to re-render all 2,500 frames of our disk cache during the project, which means it just adds to the whole overall thing. And that means every time you re-rendered your project, you'd be adding this extra time to it, whereas by rendering out ahead of time, we can just use it, and it's always there. Now, this opens up the opportunity to use, we could actually set this project, instead of using the frames directly, we could turn this into a pre-comp. I've found, I'm just going to let everybody know ahead of time, I've really found the only real pro to using a pre-comp over directly using the files is if your hierarchy for your project is not laid out in an intelligent format. The pre-comp will give you the option, and for those who don't know what I'm talking about, I don't use pre-comp, so I'm actually going to let's hit tab and pull up a pre-comp. Pre-comp right here. Okay, so here's a pre-comp. What pre-comp does is it's very similar to getting an image sequence, except for what you have to do is you select another project file. And in theory, what pre-comp allows you to do is it allows you to change your frames and render it from inside of this project. That's one of the things it would allow you to do. And the other thing it allows you to do is it allows you to edit the project, and which is cool. It means it will open the project in a new window, which if your project gets really complicated and you have a lot of different sub pre-comps that you're working with, hey, pre-comp can be a lifesaver, because it's a good way to take very, very complicated projects that would otherwise potentially cause your system to run out of memory and break them up into smaller pieces. But the big problem you run into with pre-comp, that as it currently stands, is pre-comp has this option where you're supposed to be able to change the first frame and the last frame, and I've found that it doesn't actually work. You actually have to set you have to edit the project frames inside of the project itself. So the good part about this is it lets you, the pre-comp allows you, and let me just demo it from this standpoint. If I click here, and I go, and we're in here in our EXR files, and we're somewhere else. Where did I gotta find, see, I'm not even, nope, I'll gotta find, there, we click on our project. And I said that our pre-comp, we didn't save our pre-comp. All right, well, we got to go back. Let's go back over here to our, well, I got to hit cancel for a second. Let's go back over here to this. And let's save this file here. This is our file. We'll save this. We'll just turn this into a pre-comp just because this is a good practice. We'll save the project. We haven't said it before, so we'll call this, it's a good thing to call it what it is. So we'll call it pre-comp underscore flames. Okay, because that's what we named it, and we should always give it our increment number, and we hit save, and now that's there. And then I can go back to my other project. I go to my pre-comp, I click on this, and there it is in my project. I have it linked up. I hit open, and now it's linked in here. I can take this because I've already, I actually have not rendered this out. So this would, if I try to click this at this point, it's going to throw an error. Okay. And the reason it hasn't, it's throwing an error is because we haven't rendered it out. Well, you'd think that if I hit the render button, it would render it. Sometimes. Well, it will sometimes render it, and there's ways of getting pre-comps to render in here. In all honesty, your best bet when dealing with with a pre-comp is to go and click on the edit project. And just to show you how that works, let's go back to our other one and close it for a second. I'm going to click on the edit project button here, and you can see that it opens up that project very nicely. That way I can go in here and then I can render it out. The problem with it is again, back in the other one, back in our original master project, the root project, the problem with this is that if we change the render frames here, we can't actually change them. If you hit render and it does render it out, it actually doesn't render out the entire sequence. Which is why it's always better if you're dealing with pre-comps to just render them in that project file, get it done, be done with it, and then set up your pre-comp so that from an organizational standpoint, and then when you pick your node, your write node, by the way, you should always pick the appropriate write node. Don't pick the internal encoder node. That's a no-no, in my opinion. Just pick the correct node. That's the right node. It was right one, and it will find the nodes. And we'll go back here, and this also brings up another little tip for everybody. You'll notice up here we still have this error, even though this node, this pre-comp node, is not part of our actual project anymore. I'm going to show you how you get rid of that. First of all, let's set this to from right node to none, because we don't actually have any frames going in, so we don't want it to be there. This is our pre-comp. Here, if you switch a node, you can clear an error in Natron by turning on its preview and turning it off. And the way you do that through the menu option is you go up here and you can see it says toggle preview and it's Alt-P. Well, that's good. That means if we go here and we select that node and I hit Alt-P to turn on its preview, you'll notice that the error disappeared. And then I hit Alt-P a second time and it's cleared the error, and now that can exist in my project as is. And we now have a fully functional node, and this has been about a 2-hour project overall. I think we're about the 2.5 hour mark for everything, and I think we're gonna call it at this point. So, right. Right. All right. Well, everybody have a great day, and keep on natroning.